What's up guys, my name is Preston Palmer with Student Engineering, and in this video we're going over the dot product. If you find it helpful, please subscribe. So the dot product is a way of multiplying two vectors where the result is a scalar value, or it's a vector with no direction, it just has a magnitude. Or in other words, it's just a number. So we can write that relationship out of what a dot product is with two vectors A dot B equals the magnitude of A, the absolute value of the magnitude of A times the absolute value of the magnitude of B times by the cosine of theta. And that angle theta is the angle between those two vectors. And we're going to use that later to solve some problems. So we're not going to go too deeply into what the dot product really is mathematically, but basically if you have these two vectors, vector A and vector B, we'll call this vector A, and we'll call this vector B. Well, these two vectors form a triangle right here, with this angle theta being the angle between them, this same theta, and you got this length here, we'll call it x, which is basically how far the vector B is going in the direction of vector A. And so we can write that out as the cosine of theta equals x divided by the magnitude of B. Or in other words, the cosine of theta is the adjacent over the hypotenuse, so x over B. And if you multiply the magnitude of B over, you get that x is the magnitude of B times by the cosine of theta. And this is starting to look a lot like this, right? So basically we can rewrite this as the magnitude of A times by x, or how far the vector B is going in the direction of A. That times by the magnitude of A is the dot product. And so it kind of tells us how far one vector is going in the direction of the other vector. So understanding really what the dot product is isn't as important as understanding how to use it. And the form you'll most likely use it in is that A dot B is equal to A sub x times by B sub x plus A sub y times by B sub y plus A sub z times by B sub z. So what you're doing here is you're multiplying their components together and then adding them up. As you can see, there's no direction in here. It's just the magnitude of each of the components multiplied together and then added up. And so you just get a number value. And so this, to be honest, in my experience, is the most common way you'll use the dot product. And I think the place that I've used it most is in calculus. So another interesting use of the dot product is that if we multiply a vector by a unit vector, we can find how far that vector is going in the direction of the unit vector, which is kind of what we did just barely in the explanation of what a dot product was. But let's say we have a vector f, and vector f equals 10I minus 5j plus 2k. Then we have a unit vector that is only going in the direction of the I, or in the I direction or in the x-axis. So that's going to look like 1I plus 0j plus 0k. Because remember, the square root of the sum of the squares of a unit vector is equal to 1, because the magnitude of a unit vector is 1. So taking the square root of the sum of the squares of this is just going to give us 1 squared, which is 1. And so whenever a unit vector is going in the direction of an axis, one of these is just going to be 1 and the other ones are going to be 0. So that being said, if we take the dot product of f dot u, we're going to see that the 10 is going to multiply by the 1, and it's going to add up to 5 times by 0 and 2 times by 0. And that's just all going to cancel out because it's going to multiply by 0, and so you're just going to get 10. And you might think, well, duh, that's obvious, because you could just drop the rest of this if you wanted to find how far it's going in the x direction, and you'd just get 10. But say it wasn't that obvious, and say we had something like a cube, and the unit vector went from the corner of the cube to the other corner. Well, the unit vector is going to look like the square root of 3i plus the square root of 3j plus the square root of 3k. Well, if we multiply a vector, we'll call this one f again. If we want to find how far the unit vector, or the vector f, is going in this unit vector along this diagonal through the cube, we can do that by multiplying the unit vector by the vector. And so this might come in handy at some point. And so like I said, the most common use that I've seen of it in my education is that you'll multiply their components, and that will give you the dot product, and you'll use that in other situations. So now we're going to go over some example problems to kind of put numbers into these formulas so you can see how it works. So let's say you have a vector A, again, which equals 6i plus 3.5j plus k. And so this k, we'll make this negative. And so this k just has a 1 in front of it that's not shown. It's just like a variable that has 1 in front of it. You're not going to write the 1, you just leave it. You'll leave it off. And vector b is going to be 4j plus 10k. And again, kind of like the k, the I is being left off because it's being multiplied by a 0. And so there's no I component in the b vector. It's only going in the y and z directions. And so if you want to take the dot product of those, a dot b is equal to 6 times by 0 plus 3.5 times by 4 plus negative 1 times by 10. And you'll get that the dot product of A and B is 0 plus 14 minus 10, which comes out as 4. So as you can see, that's just a number. It's not a vector, it doesn't have a direction, and that's what the dot product comes out as. It's also called the scalar product of two vectors because the result is just a scalar value. So we're going to do another example problem where we find the angle between two vectors using the first formula we talked about. So say we have a vector f which equals 2i plus 3j and a vector t 7i minus 5j. And so we see that vector f and vector t are only in the xy plane. They're not going at all in the z direction, so they don't have a k component. So remember that f dot t is going to equal the magnitude of f times by the magnitude of t times by the cosine of the angle between them, cosine of theta. And so if we want to do f dot t, it will be 2 times by 7 plus 3 times by negative 5 equals, and the magnitude is going to be the square root of the sum of the squares, so 2, so the magnitude of f equals 2 squared plus 3 squared, which equals the square root. 4 plus 9 is 13. And then t is the square root of 7 squared plus negative 5 squared, which equals the square root of 74. And so you get the square root of 13 times by the square root of 74 times by the cosine of theta. And so this is 14 minus 15 equals the square root of 962 times by the cosine of theta. And so this will equal negative 1. You divide the square root of 962 over, equals the cosine of theta. And so you're going to get that theta equals the arc cosine of this number, and if you put that into a calculator and round it out, it's going to equal negative 0.032. And if you round it out, you're going to get a slightly different answer than if you just plug this number into your calculator, but you end up getting that theta equals 88.2 degrees. And I'm going to change this because it's approximately this number. I know that if you actually put this number in, you end up getting about 91 degrees. So it is slightly different. That's why I put this squiggly equal sign to say it's approximately. So that's how you find the angle between two vectors. And that might come in handy every now and then. So that's it for this video. If you found it helpful, hit that like button. If you have any questions or suggestions, please leave them down in the comments below. And don't forget to subscribe.